With over 4 million visitors each year and numerous geysers, Yellowstone is renowned worldwide. Beneath its stunning landscape lies one of the largest supervolcanoes, which last erupted about 640,000 years ago. If it were to erupt again, it could have catastrophic effects on North America and global agriculture. A controversial proposal was made to drill into Yellowstone to harness its geothermal energy and potentially cool the supervolcano. This raises questions about humanity's desire to control such immense natural power and the risks involved. Yellowstone boasts over 500 active geysers, more than any other location worldwide, making up over half of all geysers globally. The park is located at the convergence of Wyoming, Montana, and Idaho, attracting over 4 million visitors annually drawn to its stunning landscapes. It's remarkable that many people are unaware the entire Yellowstone area sits atop a colossal volcanic caldera that spans nearly 70 kilometers. This unique geological feature contributes to the park's dynamic natural phenomena and beauty. The combination of geysers, the caldera, and the park's diverse ecosystems creates an extraordinary environment that captivates visitors. Beneath the park lies a vast magma system deep within the Earth's crust. Seismic studies indicate that this reservoir contains approximately 4,000 cubic kilometers of molten material, sufficient to trigger one of the largest volcanic eruptions in geological history. Historically, Yellowstone has witnessed 3 supereruptions, occurring around 2.1 million, 1.3 million, and 640,000 years ago. Each of these eruptions expelled over 1,000 cubic kilometers of ash and molten rock, vastly exceeding the material released during the 1980 Mount St. Helens eruption. Today, signs of this immense magma system can still be observed on the surface. I have learned that more than 10,000 geothermal features, including hot springs, mud pots, and geysers, are active throughout Yellowstone National Park. These features function as natural pressure valves that allow heat and gases from the magma system below to escape. As a result, Yellowstone has become the most studied supervolcano on Earth. To understand the underground activity, scientists monitor even the smallest movements and changes within this complex geological system. The monitoring program is one of the most sophisticated in the world and is operated by the United States Geological Survey in collaboration with NASA and several universities. I have observed that dozens of high-precision GPS stations installed across the park can detect ground elevation changes as small as a few millimeters per year. When magma shifts beneath the surface, the ground above behaves like a giant lung, either rising or sinking. Additionally, more than 40 seismometers are in place to continuously record the tiny vibrations caused by the 1,000 to 3,000 small earthquakes that occur annually in Yellowstone. These minor tremors assist in identifying the movement of magma deep underground. Researchers are also analyzing gases from hot springs, which led to discussions in 2015 about a new strategy to reduce the risk of a supereruption by extracting heat from the volcano to generate electricity. I have learned that humans have utilized geothermal energy for decades through power plants in places like Iceland, New Zealand, and California, which generate electricity using steam from deep underground. Yellowstone National Park, however, possesses a vastly larger underground thermal energy source, estimated to be around 6 gigawatts. If a portion of this heat could be harnessed, it could yield approximately 0.6 to 1.2 gigawatts of power, enough to supply electricity to 420,000 to nearly 1 million homes in the U.S. This approach offers a dual benefit. It could provide a clean and stable energy source while also helping to cool the supervolcano over time. By tapping into this geothermal resource, we might prevent Yellowstone from accumulating heat over the ages, effectively draining energy from the system instead. I find the concept incredibly ambitious, as it requires engineers to drill several kilometers deep into the magma system of a supervolcano. The original proposal involves drilling a well about 6 miles deep, which is nearly 10 kilometers. To highlight the extraordinary nature of this depth, I consider the Kola Super Deep borehole, which reached 12,262 meters and took nearly 20 years to complete. I realized that drilling straight down into Yellowstone National Park would be impossible due to a thick layer of rock above the magma chamber that acts like a giant lid. Therefore, NASA's plan suggests drilling from outside the park and angling the well downward to reach the outer edge of the magma system. I learned about directional drilling, a technique used in the oil and gas industry to access deep reservoirs. The initial drilling phase involves lining the borehole with heat-resistant steel casings and monitoring various geological parameters. The project's ultimate aim is to establish a large geothermal system that functions like an underground power plant. Successful construction of the well is crucial for the system to operate using a familiar geothermal energy cycle. This involves pumping cold water under high pressure into hot rock layers, where it can reach temperatures above 400 degrees Celsius, entering a supercritical state. In this state, I observe a fluid that is neither a normal liquid nor ordinary steam, but an extremely energy-dense fluid capable of carrying vast amounts of heat. I note that this superheated fluid is brought back to the surface through a second well. Once it reaches the power plant, the pressure drops, causing the fluid to rapidly convert into high-velocity steam. The steam then spins a turbine, which drives a generator to produce electricity, similar to a traditional thermal power plant. Finally, I learned that the water is cooled and pumped back underground to restart the cycle, and scientists have found staggering results regarding the heat stored inside Yellowstone's magma chamber. To significantly reduce the risk of a supereruption, I would need to cool the magma system by at least 30%. Achieving this level of cooling, even with a continuously operating geothermal system, could take thousands of years. This means the project would have to span multiple generations, governments, and waves of technological change. The environment near magma is extremely hostile, with intense heat, enormous pressure, and corrosive gases that can rapidly destroy materials. Experiments in geothermal drilling in Iceland reveal that equipment can fail within just a few months of operation at depths of only 2 kilometers. Conditions beneath Yellowstone National Park are particularly challenging due to higher temperatures, greater pressures, and a complex chemical environment. No existing technology is considered reliable enough to operate a deep drilling and geothermal system there for extended periods. Drilling into Yellowstone raises concerns about unpredictable consequences, as history shows that even shallow drilling can trigger unexpected reactions. During 20th century exploratory drilling, reaching layers of superheated water caused the well to shoot steam and boiling water back to the surface, affecting nearby hot springs. These events highlighted the extreme sensitivity of Yellowstone's hydrothermal system, which consists of a vast network of interconnected fractures, channels. Disturbing one part of the system can influence other areas far away, and a 10-kilometer deep well could potentially alter the pressure balance across the entire underground system. Yellowstone is not only a supervolcano, but also the first national park ever created in the world, established in 1872. The park covers nearly 9,000 square kilometers and remains one of the largest and most intact wilderness ecosystems left in North America. Today, Yellowstone National Park is home to more than 5,000 bison, which is the largest wild bison population on the continent. The park also shelters many iconic predators and rare animals, including grizzly bears, gray wolves, lynx, and wolverines.
The reintroduction of wolves in 1995 became one of the most famous examples of a trophic cascade in ecology.
The reintroduction of wolves in 1995 led to significant ecological changes, including a decline in elk populations and a recovery of vegetation. This recovery allowed for the return of various birds and small animals that rely on healthy forest environments. Yellowstone is home to over 300 bird species and unique extremophile microorganisms, some of which thrive in extreme temperatures. These microbes have contributed to the development of important scientific technologies like polymerase chain reaction, PCR. Due to the park's delicate ecosystem, large-scale engineering projects and commercial drilling are prohibited under U.S. federal law established in the 1970s. Drilling deep into volcanic systems to study or harness their energy is a common practice among scientists. Over the years, bold experiments have been conducted in various locations, with Iceland being a notable example due to its position on tectonic plate boundaries. In 2009, the Iceland Deep Drilling Project unexpectedly encountered magma at a depth of around 2 kilometers, with temperatures nearing 900 degrees Celsius. This incident turned into a significant experiment when water pumped into the well generated superheated steam that produced approximately 36 megawatts of electricity. Another notable project occurred at Campi Flegrei near Naples, where international researchers drilled deep to investigate the geological structure of the magma system. The project quickly became controversial as some feared that drilling might trigger volcanic activity, yet provided valuable scientific data about magma and hydrothermal systems. The plan to drill deep into Yellowstone National Park remains only a concept on paper, reflecting humanity's desire to understand and control powerful natural forces. Yellowstone represents a massive energy reservoir that could potentially supply electricity to millions, but it is also a complex geological system that scientists do not fully understand. Even a small mistake in this endeavor could lead to irreversible consequences. I invite you to share your thoughts on the idea of drilling into a supervolcano and to subscribe to Engineering Frontier for more fascinating science stories.